Okay, continuing on with Chapter 9, Examining Point Data Objects. We're now looking at the pedon object in the pedon tables. And what we've done, I'm going to go ahead and I moved into the pedon table. I'm going to then do a best fit all columns so we can take a look at this. And I've chose the actual TUD that was sampled for that particular county, not sampled, but described for that particular county, 1957. And so you can see that the observation date was recorded, and you know it was 1957 because the user pedon ID and the user site ID start with 1957 KS075035. And we're going to scroll across here, and even though I described it, even though my name's on there, I think I was just too lazy to put down the original author's name. Notice that this is dimmed out, the current taxon name, current taxonomic structure, and the current taxon kind. These are dimmed out because they actually are not in this table. They're in a child table. We display them here for the benefit of you knowing where this information particular pedon is. It's a Bridgeport pedon. So we also have the pedon type, and we've got a choice list, and the choice list has changed over the years. It's now the confirmation description correlates to the named soil, the OSD pedon, the representative pedon for the component, taxonomic, a TED pedon, and undefined observation. Now this has changed over the years since I put in this particular pedon. Now that would probably be a TUD pedon because that's what that particular one was. And then once again, the pedon purpose, we can identify several different features. One thing nice about the pedon and point data is that almost everything is entered based off of a choice list, so it really helps speed up the process. The certified pedon description, lab pedon description, this is going to be used to provide the pedon that is going to be linked to the lab data that's on the web. And so whatever is the most current or official set of data will be checked, and this is what the report for the KSSL web page will look for if there is multiple pedons on that one particular lab set. Our exposure site and then the unit of measurement, the crop cover kind 1 and crop cover kind 2, your erosion class. So all of this information is information pertinent to that particular pedon that you're about to describe. Here's your transect information. I'll make a note of this right now. If you've run a transect and you've entered your pedon, you've collected your pedon data, before entering any pedon information, go to the transect and set up the transect first so that you have that transect information when you start putting in your pedons, because pedons are linked to a transect, and this is where you'll want to be able to populate the transect information as you're putting in the pedon. Remember, always enter the transect table first if you've got a transect so that you can populate your pedons with that transect information. And then you've got your RACA point number, your soil replicate number. So a lot of this information is pertinent to DSP or RACA type information. So you can see most of this. If you're not familiar with how it's populated, all you have to do is go into your view information, and then from your view information, it'll provide you the information you need. So that gives you a rough overview of the pedon table, and then you'll notice that we've got quite a few child tables, horizon being the default, and then after the default is by alphabetical order the diagnostic features, the field measured properties, and all of the other child tables. So we're going to go over here into the pedon horizon. We're going to open this up and take a look at it. You can see life has changed quite a bit over the years, the way we describe soils. I'm going to do a best fit all columns. And I'm going to grab this banner, move it on over here, and right click and do a freeze column just so we can keep track of where we're at. Now, you're going to come in here and you're going to populate your master, your prime, your sub, your discontinuity, and then you're going to calculate your designation. And designation also has other child table that has to be populated, but I'm going to use the destination, pardon me, designation and top depth as a reference as we scroll across here. Here's our observation method, which was the how did you actually view that particular sample. Once again, you'll notice I went too far. Your textural modifier in class, it's dimmed out. We provide it here so that you can understand what that particular texture is, but that information is in a child table and it's calculated and provided to you in this table. And then you have your estimated clay content, estimated silt content, estimated sand content. It is really critical whenever you're out taking descriptions that you estimate at least 2 of these 3. You need to get into the habit of doing an estimated clay and estimated sand so that you can refine your properties when you sit down and start analyzing your PET-ON data needed to be able to populate your aggregated data. So get into that habit. Your total fragment volume, your variegated colors, your observed soil moisture state, was it moist at the time you sampled it? And then you've got all of your rupture, manner of failure, your stickiness, your plasticity, penetration. So you can see that you got quite a bit of information that not every single PET-ON uses, but those that are pertinent to your particular needs to be populated. And just out of a side note, I showed you this profile from 1957, and I'll contrast that with this profile in 2001 that was described at the same location and just 50 years later. So you can see that we've done quite a bit in the way that we describe soils. So something to consider, that quite interesting when you look at it, the way we've changed things. So we now have quite a few, a lot of child tables under the horizon. So you can see that we're going to go into those here in just a minute. But we've got the diagnostic features, the field measured properties, and a field measured property is a table that allows you that if you do not have a specific data element in the NASIS database to be able to put in a particular, for example, organic matter, not organic carbon, organic matter. You could come in here if you were measuring organic matter, you could literally create a name and say what I want, or I want to populate organic matter, and I could put in the value of 2, and I could put in the unit of measurement of %. And this would allow me to capture that information in the database so that as I collect a myriad of samples, I still have a location to be able to put this information so that I can analyze it in the future. But keep in mind, database lives or dies based on the consistency in which the data is populated. So if you populate this organic matter the way it is here, always populate it the same exact way. If it's OM, always OM. If it's all lowercase, it's all lowercase. PET-ON hydric field indicator. Once again, here's your choices, and all you gotta do is just choose the choice if that's the case for your particular indicator. Infiltration summary sheets. I know that can't be blank. Here's your infiltration summary if you're doing an infiltration study. PET-ON penetration resistance, restrictions, if you have any restrictions in your soil, stability, if you're doing a stability test. Here is your Pedon taxonomic history table. I'd explained to you earlier that these fields up here are not populated in the Pedon table. They're literally populated in the Pedon taxonomic history table, and we allow them to appear in the Pedon table. Now, the way this works is that here's the classification date. This allows you that if you come back in and do a correlation, for example, this one was originally sampled as Bridgeport, but it did not meet the classification for Bridgeport, so it was identified as a series not designated yet, pending a further study. Here's your Pedon class. Well, this is dimmed out also. That automatically tells you that there is a child table, and lo and behold, there are child tables that go in here and populate for that for those particular fields. So we do have other fields that need to be populated before this can be calculated. So here is the order, suborder, and all the remaining taxonomic fields. And then once these taxonomy fields are all populated, you can then come in and calculate and retrieve the taxonomic class. So that gives you an idea of some of the child tables. Pedon text. This Pedon is a redescription of the Hamilton County typifying Pedon for Bridgeport. Can be compared with the same number. Original would have been classified, And then soil monitoring data if you have any station information that you want to be able to monitor. So we have made this a very robust system of collecting a massive amount of information on a particular point. And you should be able to meet the needs of any data collection that you happen to have. Now, returning back, I'm going to open up the Pedon texture, and then you'll notice you got a plus and you've got a modifier, just like you do in the component horizon. The Pedon horizon has a modifier and a texture that have to be populated in order to calculate the texture here in the horizon table class. Then we've got the bulk density. We have really started making a push on bulk density and trying to get people to populate bulk densities. This is your estimated bulk densities while you're in the field, not the one that's collected for the lab. Here's your cementing agents, your Pedon colors, your concentrations, your cracks, your designation suffix. Remember, that's critical because their designation suffix is part of your designation. It is a child table, and the reason why it is a child table is because you can have more than one designation suffix. Your Pedon horizon features, if you have populated any features for that particular horizon. You also have the ability to do a field measured property in the particular horizon. So I could have done the same thing. I could have said, for here, I want to do the organic matter for this particular horizon. And then here it might be 0.5 and it's a %. So you have the field measured property for the Pedon. You also have field measured properties for the horizons. And then you have the fragments, where you go in and populate your fragments, your human artifacts, your KSAT summaries. This is where you summarize your data and populate it. Here's your Pedon lab results. The lab results table has quite a few features. Total clay measured. This is the information that you've sampled, you've taken back to your lab in your office, and you run the clay and the silt and the sand. You can come in here. If you've sieved, you have the ability to capture the sieve weights and put those in here also. Now you have the you can also come in here and put in all of the information that is available for your particular office lab. Here's the texture class based off the field lab, and that could be totally different from the texture class that is in your particular estimated while you were in the field. Here's all your pH, your liquid limit, your PI if you happen to run those, your Atterberg sample condition. All of these are the results of analysis that can be done in your lab. Then you have the models, you have the surface features, the pores, the redox features, the roots, your samples that you may have collected, your structure, your texts, and your VNIR scans. So that gives you a rundown on the PET-ON table and all of the variety of tables and columns that you've got to be able to deal with. And this will end this video. It went a little long, but I wanted to wrap up PET-ON in one video, and then we'll move into transect, and we'll move into site association in the next video. So we'll talk to you then.